Welcome to part 1 of Competency 15 quiz. In this video, we will work with mathematical reasoning. Number 1, in establishing the indirect proof, that's in general any indirect proof, which one of the following is necessary? Well, we need a contradiction, but that's a must. You have to have something that's opposite, and by that, it implies a contrary contradiction. Okay, let's look at A. A statement that verifies the assumption? No. A statement that contradicts the given assumption? Yes. You want the opposite or some kind of a contradiction. Absolutely. Let's read C and D. A geometric drawing, that doesn't make any sense. And D, an algebraic explanation. Now, an algebraic explanation is something you would lean towards in most cases for a direct proof. So that's not what we need. Okay, so B is obviously what we need. So go to, okay, let's look at 2. Okay. Use the figure and the proof below to answer the question that follows. Given, okay, this is just saying this is in the given and this is the proof. This is like the way we would write a proof if you're not used to proof writing, okay? All right, in triangle ABC shown, AB is greater than BC. Okay, so I'm going to make some little marks to help us out here. Okay, fine. And then it says this is a measure of, okay, oh, I'm sorry. That's just the legs. Okay, now they're going to the proof. First we have our given, now we have our proof. Angle A is not equal to angle C. Okay, I buy that. So I'm going to do some marks for us to help us out. Okay, all right. In all honesty, this is a scalene. We are looking at a scalene triangle. But we need to prove by contradiction that we have a scalene. Well, what's opposite of scalene? Well, you could try for equilateral. Okay. Isosceles. Right triangle? Probably not. I wouldn't go with right triangle because a lot of right triangles are scalene, so that wouldn't work. So I've thrown out some ideas. I wouldn't go with acute. That I don't think that would help us. But let's keep reading and see what it says. Okay? Prove by contradiction, assume that angle A is congruent to angle C. Absolutely, that makes sense. And that is how you would start. If angle A congruent to angle B, then, okay, so if they're congruent, that means that the segment AB is congruent to segment AC. Okay, I'm going to draw that. That's what you have. What do you see, ladies and gentlemen? I see an isosceles triangle, and I did suggest that we could start like that. So I'm thinking by the isosceles theorem, however they want to state it. I haven't read ABCD yet, but let's keep reading. However, this theorem contradicts the given information that AB is greater than BC. Therefore, the assumption that angle A is congruent to angle C must be false. And so the measure of the angles cannot be equal, and angle A is not equal to angle C. In this proof above, which one of the following theorems correctly fills in the blank? I bet you already see it. Let's look at A. Corresponding angle theorem? No. That theorem is what you're looking at in the given triangle they drew. So that's not it. Let's see. Angle bisector. Oh, there is no bisector. There's no bisecting going on. We're not slicing anything up. C, isosceles triangle theorem. Oh, I totally think that's it. I believe it. Okay, now let's look. Congruent, at D rather. congruence of triangles with the side property, that is not involved here. So notice I didn't use my calculator, and also notice all of these theorems and properties are all commonplace. You need to know them. And you do not have to teach high school in order to be aware of these and use these in the classroom. There are times when this will come up in the middle school setting, okay? All right, let's look at number 3. Number 3, in the figure below, CB is equal to 8 and AC is equal to 10. Which one of the following statements should be used to prove indirectly that the area of triangle ABC is less than 40? Okay, we need base times height divided by 2 for any area of a triangle. Okay, so what you're doing is you're saying, okay, I have a base. Well, what do I need for my height? And you need it to be less than 40. So logically, side note, tackle that fact, which is the end result. I'm going to go with my end result and then see where I need to start. Let me show you what I mean. Base is 8 times a height that I don't know. Okay, right here, because I'm trying to find the area of this triangle. Okay? Okay. Base times height divided by 2. All of that needs to be less than 40. Now go through the algebraic process, and that will get me h is less than 10. Let me show you on my calculator. Okay? You would have this. First, let me set up my fraction. Let me just do it again. There we go. Okay, I would have 40, okay, as a numerator, times a 2. That gets rid of 2. Now you need to get rid of the coefficient of 8 in front of the h, so go down and divide it all by 8. And that gives me 10. So indirectly, I need to begin by showing that h, the height of AD, I'm going to call that h right here, height, is less than 10. So I would show that restriction, and then I would have to move to how to show that. So that would be my first step. And the question is, which of the following statements would be used to prove? Well, we already know that you have to use that. So let's look at A, B, C, and D. A is about the measure of angle, actually angle C, ACD. So that would be angle C. So no, that's just talking about angle. B, the measure of angle B. No. C, determine the restriction for the value of AD, which is our H that we've written up. Yeah, you have to use that because it has to do with finding the area of any triangle. And in particular, this triangle, okay? And let's look at D, restriction of AB, that's where the R is. So no, that's not something we're going to use for area. Okay, so that gets rid of D, and that proves option C is the only reasonable selection. Okay, let's go to number 4. One of the two given statements is all books in this library are for sale. Suppose the conclusion using deductive reasoning is the book Oliver Twist is for sale. Okay, that's a conclusion. Okay, that's a specific book. All right. Which one of the following would represent the second given statement? So we have our beginning and we have our conclusion. And it says deductive. That means we're general to specific. which we've done. We've gone from just any book in the library to a specific book in the library. Well, the next step in the middle somewhere is something that would make the connection that Oliver Twist is even in said library. So something has to be said saying that Oliver Twist exists in that library on a shelf somehow. Well, let's look at A. Oliver Twist is a book in the library. Absolutely, that would be a good statement. But let's keep reading. B. Oliver Twist is not a book in the library. That's a contradiction. So that's not what they want us to do right now. C. All books for sale are in the library. That doesn't help us. That would be, isn't that just all books for sale are in the library? All books in the library are for sale. That's like the same thing. So that's not helping. Okay, D. Some books for sale are not in the library. That doesn't help us either. That's a different conclusion. So the only reasonable answer was A. Okay. All right, so let's look at 5. A claim is made that the product of two positive numbers is at least as large as either number. Which one of the following provides a counterexample? Okay, let me write out what they're saying to begin with. In general, they're saying, let's say we had X and Y. Those two things, okay, equal P product. The product of two positive numbers. Well, X and Y are my two positive numbers. So what the next step says is that at least as large as either number. So they're saying X is less than or equal to P, and Y is less than or equal to P. They're at least as large, but not larger. Okay? Now be careful with this. Wrap it around your head. It took me a second when I read through it the first time, very quickly, I might add. They're not saying as least as large. They're not saying uh, anything about being greater. They're going to be less than or equal to. There's no other way to see it. Okay? Now, let's look at A, B, C, and D. Okay, so you have to like analyze each one. Well, 8 is equal to 8 for A. That's a check. That can happen. And 1 is less than 8. So we want a counterexample. A is an actual example. Let's look at B. Well, 6 is greater than P, which would be 3. So I'm going to say that B is a definite possibility because it implies that our X is greater than our P, which in turn is a contradiction. And if you look at our given, it says positive number. It doesn't say anything about the value of said positive number. And a half is a fraction. And a fraction does change the situation because technically a half multiplying by half is the same as dividing by 2. Okay? So I'm going to say that very possibly B is what we need. Okay, but let's look at C. Okay, first C, whoa, C and D, but let's look at C. Okay, the radical, under the radical of 10, the square root of 10. Okay, you got to do your toggle. Well, that is less than 20. So that checks out. Okay, so then obviously, if that's going to be less than 20, let's see about the square root of 40. Square probably should have done 40 to verify because if 40 is less, then 10 has to be less. Well, it's still 6. You know, six-ish. Okay, so that checks out. So that verifies the given assumption, so C's out. Well, obviously 3 is less than 10, and pi, it's never ending, but it never becomes 4. It might get close to 4. We don't know how close it gets to 4, but we know that pi will never be 4. We know that it's somewhere between 3.14 and 4-ish. So, option D, again, it proves the given assumption. B is the only counterexample to that assumption because a half is technically divided by 2. Okay. All right. This is the last question in this video. I hope it was helpful, even though we didn't use the calculator a lot. What we did is we used the calculator to prove what our thoughts were or where to begin, not really to do any great calculation. Sometimes it happens that way. And I'll be honest with you guys, if you don't have a 4-year degree in math, which you don't have to teach middle school, trust me, it's not necessary. Okay, you can be a very effective teacher without that degree. However, a greater understanding of mathematics comes when you are dealing with proofs and proof writing. Although, in all honesty, a very frustrating road to get to that greater understanding. I've done it. I absolutely understand some of the grief while you guys are studying. I Kudos to you. More power to you, more strength. You're the best. And think about it. You got this far. Don't give up. You can do this. Okay. And thank you so much for watching, subscribing, liking, and sharing. Happy testing, everybody.